Alright, so this is homework 7.2, and we're going over polynomial functions. And the first question has three parts. We want to determine the end behavior of the graph for part one. So I'm going to go ahead and write this function down. N of x is equal to negative 5 times x plus 1. And then we have 2x plus 2 to the third. And then we have x plus 6. Okay. So when it comes to determining the end behavior, we have basically two things to look at. We're going to look at the power. It's either going to be even or odd. And we're going to look at the leading coefficient, which is also going to be one of two things. It's going to be positive or it's going to be negative. Okay. And so here, if you go through the textbook, you get a good idea of it. But if it's even and positive, both endpoints will go to the positive infinity. So we don't really care about what's going on in the middle. We're just talking about the end. So we say as x goes toward positive or negative infinity, f of x, which is the y value, goes, it's like an arrow toward positive infinity. So even, positive, they both go the same direction. Same, even and negative, they both want to go down to negative infinity, both endpoints. Okay. So again, this is as the x value goes toward positive or negative. And usually we'll do one at a time, but I'm just doing both because x goes to the left, the y value, which is f of x, is going toward negative infinity, and even as x goes to the right, it's going toward negative. So this is the idea. If it's odd and positive, the right end goes up and the left end goes down. Okay, so as x goes to positive, y goes to positive, and then when x goes to negative, y goes to negative. The f of x goes to negative infinity. When it's odd and negative, it just flips. So they do the opposite. So odd and negative, as x goes to positive, f of x or the y goes to negative, and then as x goes to negative infinity, y value, f of x goes to positive. It just flip-flops. So even, they both go up if it's positive, both go down if it's negative. Odd, right is up, left is down, the signs match. And if it's odd and negative, the signs are going to be flip-flop. How do we determine that from this function? Well, we look at the degree. We count how many x's. So this is 1. Here's another x, but it's raised to the third power. So we're going to add them up. So this is 1 plus 3. That's going to give me 4. Plus 1 more, that's going to be 5. So I'm looking at degree 5. Degree 5. Okay, so that's my power. That is odd. So I'm looking at this case or this case. This leading coefficient is negative. So we are looking at odd and negative. So our end behavior is x goes to positive, y goes to negative, and when x goes to negative, y goes to positive. We can graph this in a calculator, we can see it, but this is in factor form, so you can just kind of count those. So we're going to put, it says determine the leading term, multiply the leading coefficients to form that factor. So right now it is wanting to multiply this x, this 2x to the third, and this x. And we're going to multiply times 5. So x to the third is x cubed, and then 2 to the third is 8. So we're looking at negative 5 times x times basically an 8x cubed, and then times another x. This is going to give us 5 times 8 is a negative 40, x to the 5th. So this is going to give us our leading coefficient, and that, our leading term, and that pretty much dictates the end behavior. So we are looking at a negative 40 x to the 5th. All right, it now says the leading coefficient is negative. That's the negative 5. The degree is odd. By the leading term test, the end behavior is blank to the left. So on the left, oh, I'm sorry, I didn't realize how far off the screen this was. Just a little bit, but the leading term goes up when we go to the left, up to the left, and down on the right. So this is kind of what we're seeing or getting from here. And then part 3, this is the math text. It says as x goes to negative, so going to the left, the y value, okay, the n of x, whatever letter they use, is going to positive infinity. And then as we go to the right side of the graph, so as x goes to positive infinity, so we're going to the right, the y value is going down to negative infinity. Up on 1. And so that will give us our end behavior.